Welcome to our training series on Performance 7 solar panels. I'm Shahla Flynn, the training manager at SunPower Australia. I'm joined by Chris Brown, one of our regional sales managers. Today, we're diving into the innovative features and the superior benefits of Performance 7 that makes this an exceptional solar panel.
SunPower and Maxeon has been at the forefront of the solar industry for many years. What does the Performance Series module bring to the market?
The Performance 7 panels feature the cutting-edge N-type TOPCon solar cells. We know that TOPCon cells have quite few advantages over the standard PERC cells that once dominated the market. To name a few, TOPCon cells have high conversion efficiency, low temperature coefficient, reliable low light production, and low annual degradation rate. But hold on, this is not the whole story. The Performance 7 panel represents a significantly different technology than the typical TOPCon panels you would find in the market. While the Performance 7 uses TOPCon solar cells, the cell is cut into 1/3 strips, which are then shingled together to eliminate the gaps between the cells. No gap between the cells means utilizing the whole panel area to capture more light and boost power generation from the panel. Now let's go through the main benefits of a 1/3 cut cell over a full-size cell. Reduce resistive losses, improving the panel efficiency and performance. Cutting cells in 1/3 reduces the current through cells and therefore lowers the resistive losses. This results in a gain in power per square meter. Extended panel lifespan. The reduced current in the smaller solar cells also means less heat generation within the cell. Not only power degradation due to thermal effects is minimized, but also the risk of cell cracking and other forms of cell damage will be reduced. Using smaller solar cells in the panel lessens the mechanical strain as well, reducing the likelihood of microcracking in the panel. All these promote extended panel lifespan. Reduce risk of hotspot formation. When a panel is partially shaded, a large amount of power can be dissipated in the shaded area of the cells, which can result in a local overheating of the shaded cells or hotspots. Smaller 1/3 cut cells produce less current than that of a full cell, which in turn reduces the amount of dissipated power in the shaded cells, mitigating hotspot damage.
So Sharla, we've covered off module efficiency and performance. We've discussed extended module lifespan. And lastly, we've talked about the reduced risk of hot spotting. What about shading?
Smaller 1/3 cut cells improve shade tolerance over standard full-size cells. Think of smaller cells as independent workers. If one gets shaded, the other cells keep working hard and the whole panel doesn't suffer as much. Apart from integrating the smaller cells to minimize the shading impacts, the internal circuitry in the panel also plays an important role in the shade management. When the panel experiences shading, the shaded area effectively becomes a bottleneck to the current flow across the entire panel. Changes to panel current and voltage may require bypass diodes to activate to protect the panel from overheating. The resulting voltage and current changes are dictated by the cell size, the number of circuits, and bypass diode arrangement. These factors change from panel to panel. The cells in Performance 7 panels are connected in 3 parallel substrings connected in series. Moreover, the panels consist of 3 distinct electrical sections, each managed by a bypass diode. During normal operation, the current flows from one side of the panel and returns to the other side. This internal circuitry design allows the current to be redistributed as necessary to optimize panel performance. Based on our R&D shade modeling, in a spot shading scenario, the Performance 7 panel experienced a 26% power loss. In comparison, a standard TOPCon solar panel showed a 35% power loss under the same conditions. This shows that the Performance 7 panels had 26% lower power loss than standard TOPCon panels. When shading was on the short edge of the panel, the Performance 7 panel experienced a 32% power loss, whereas the standard TOPCon panel showed a 41% power loss under the same conditions. We can see again that the Performance 7 panels had 22% lower power loss than the standard TOPCon panel. When subjected to shade on the long edge, the Performance 7 panel experienced an 11% power loss comparing to a 35% power loss in a standard TOPCon panel under the same conditions. This is equivalent to 69% lower power loss, demonstrating that once more the Performance 7 panels outperform the standard TOPCon panels. Now let's talk about another crucial feature of the Performance 7 panel that further promotes its reliability: the flexible joint cell connections. Unlike standard panels with rigid joints, which make them prone to ribbon failure and cell cracking, the Performance 7 panels boast specially engineered flexible joint cell interconnects. These innovations provide unparalleled durability, safeguarding against temperature swings and excessive movement. The Performance 7 panels undergo rigorous testing, surpassing industry standards for thermocycling, ensuring reliability even in the toughest weather conditions. Later in this video, I'll go through some of the critical testing and certifications that Performance 7 has achieved, so stay tuned. Continuing on the innovative technology behind the Performance 7 panel, these panels are designed to withstand some of the most challenging environmental conditions. Using double-layered glass construction, the Performance 7 panels offer robust protection against extreme weather conditions and insulation stresses, promoting durability and longer lifespan. SunPower uses a different and better encapsulant. The POE encapsulant in the Performance 7 panels provide excellent moisture resistance, keeping harmful water and moisture at bay, preventing corrosion, and thereby enhancing long-term production even in the harsh environment. The Performance 7 panels ensure the highest quality by meeting the base and the requirements of additional standards. Now let's explore some of the significant certifications of Performance 7 panels, which give installers and consumers the critical information they need to select the panels that are appropriate to their installation environment. Firstly, Performance 7 panels are tested for 40 mm hail resistance, ensuring durability against severe weather conditions. This robustness is critical as hail can cause substantial damage to solar panels, reducing their efficiency and lifespan. These panels have passed stringent hail impact tests, demonstrating their ability to withstand hailstones at high velocities, which is a testament to their superior build quality. Next, Performance 7 panels have achieved the highest severity of salt mist corrosion resistance, test method 8, according to IEC 61701. This standard has been updated to align with the latest edition of IEC 60068-2-52. These updates provide a more comprehensive evaluation of panel performance in real-world and harsh environmental conditions. This certification means the Performance 7 panels can endure extended exposure to salty environments such as coastal areas without significant power output decline. Furthermore, Performance 7 panels boast IEC 62716 ammonia corrosion resistance, which is crucial for installation in agricultural areas where ammonia can be present. This resistance ensures that the panels will maintain performance even in high ammonia concentrations, safeguarding your investment against ammonia-induced corrosion. Moreover, the Performance 7 panels have attained a Class A fire rating result from TÜV. With a glass-glass construction, these panels perform very well in fire tests. Class A fire resistance is the highest rating for solar panels, signifying they can slow the spread of flames and limit smoke development, adding an extra layer of safety in the event of a fire. Lastly, the IEC TS 62804 PID resistance is another critical feature of Performance 7 panels. Potential induced degradation, or PID, can significantly reduce the performance of solar panels over time. The Performance 7 panels are designed to resist PID, ensuring long-term reliability and consistent power generation even under high voltage stress conditions in damp environments. In conclusion, these certifications and resistances highlight the technical superiority of the Performance 7 panels, ensuring they deliver optimal performance and longevity in various challenging environments. This makes them an excellent choice for a wide range of applications, from residential and commercial to large-scale installations. The Clean Energy Council has also validated these results by awarding SunPower from Maxion solar panels with enhanced listings in all the above categories. As you can see, these remarkable design elements incorporated into the Performance 7 solar panels provide unparalleled durability and reliability. What's even more impressive, these panels come with a comprehensive, best-in-class 30-year warranty for added peace of mind. For further details on the Performance 7 warranty, be sure to watch our dedicated video on this topic. Alternatively, please feel free to contact us to find out more. We have a dedicated team of application engineers and solar experts willing to support you.